Hello friends, in this video we will discuss a problem based on gravitation. So there are two satellites S1 and S2 of equal mass and they revolve in the same sense around a heavy planet in a coplanar circular orbit of radii r and 4r. Now we have to find the ratio of their time period of revolution as well as their velocities and angular momentum. So let us start solving this problem. So it is given to us that there are two satellites which are orbiting around the planet and orbits of radius r and 4r. Let us first draw these two orbits. So this is the first orbit and we have this second orbit as well. Now there are two satellites. First one is S1 having mass m and radius of this orbit is r. For this second satellite, mass is m and radius of this orbit is 4r. Right? So we have to find in option A, we have to check whether the ratio of this time period is equal to 1:8. As it is asked in option A, the ratio of period of revolution is 1:8. So let us first find this time period, the ratio of this time period. We know that t square is proportional to r cube. Now we can directly write t1 by t2 square will be equal to 1 by 4 cube. So from here we can write the value of t1 by t2 will be equal to 1 by 8. That is option A is correct option. Now let us shift our focus to their orbital velocities. We know that for a orbiting satellite, its orbital velocity can be written as the orbital velocity of a satellite can be written as root of gm by r. From here we can find the value of v1 ratio v2, that is r2 by r1, which comes out to be equal to 2:1. That is option B is also correct. Now let us find the value of omega 1 when both these satellites are at this particular positions. I am referring to their velocities as v1 by v2. So now relative angular velocity of satellite S2 with respect to S1 will be equal to omega 1 relative will be equal to v relative upon r relative, and this v relative will be equal to v2 minus v1. When both the satellites are in this position as shown, I can write v relative will be equal to v2 minus v1 divided by r relative, that is this relative distance between these two satellites, which is r2 minus r1. Now for second position, which is asked in the problem, when both the satellites are at diametrically opposite ends, we can write omega 2 relative will be equal to again v relative by r relative, but this time relative speed will be equal to v2 plus v1 since both are moving in opposite directions. So relative velocity of satellite 2 as seen by satellite 1 will be equal to v2 plus v1 divided by the relative distance between them. This time this distance is equal to r1 plus r2. Now we can find this ratio by substituting the values of v1 and v2 as well as r1 and r2. This ratio on simplification comes out to be equal to 9 by 5. That is option D. The ratio of angular velocities of S2 with respect to S1 when all the three are in the same line is 9:5.